Welcome back once again to the next part of your solving by undoing notes. Hopefully by this point you've kind of seen the structure of what that do undo table will do for us. But remember, we're still working through the notes here, so we're going to keep including the do undo table along with showing the steps algebraically. Once we get to that practice, which we'll start today, and if not, then definitely the next time that you guys are in class, you'll end up um, being able to drop that do undo table, but still thinking of it in terms of that process of the order of operations and then how do you undo those. And that really gives you a path to work through any of these equations where there's a single variable with which you have to isolate. In other words, visually speaking, you only see that one variable. All of ours we've gone with have an x. Um, so more specifically today, we're going to work with a couple of your other inverse functions. You see we're going to have trig functions, we'll have exponents and logs, and then we'll have these power functions. In other words, most of those will have rational exponents. So we'll see how to kind of undo each of these and then add that to your toolkit of inverse functions that you can use. So we'll start with the trig functions. And I will say we're going to simplify this a little bit with those trig functions. So if I go back in the notes and I look at the directions that are here, you'll notice that last part it says for trig equations, use radians. So make sure your calculator's in radian mode. So go into the settings and then or the mode and change that over to radians. And the other thing is the principal value. What the principal value is it's really calculator driven. Because if I start to use sine and cosine values and I solve for those in equations, there actually could be infinitely many solutions for a lot of these trig equations, even the ones that I'm going to give you. But I'm not going to ask that you find those infinitely many solutions or represent those infinitely many solutions. So the idea with the principal value is I want you to find what would be considered more so like your right triangle trig answer. So when you started right triangle trig, everything was in terms of acute angles because those were the two angles that were left over in a right triangle, right? If you have a right angle as one of your angles, 90 degrees, then your other two angles are going to have to be acute angles. So that was never an issue in terms of solving for acute angles when you're using sine and cosine within a right triangle, because the calculator, when you solve for those angles, use that inverse, would always kick out an acute angle. But those aren't the only angles, obviously, that you could have in a triangle or that you could potentially solve for some of these different equations. So to kind of make a long story short here, for now we're going to simplify it. We're just going to use the principal value, kind of see what that looks like here in just a moment once we start this first equation. Later on, what we'll do is we'll look and see what does it mean if we removed that restriction of saying I only want the principal value from the calculator. So let's get into the equation here. In your first equation, 45 equals 40 plus 10 cosine of x minus 2, so number 25 there in your notes. So we'll set up the do undo table. And once again, you're looking at x and you're saying, okay, what are all the things that are being done to x in that order of operations? So the first thing is you would subtract 2 from x. And then if inside that cosine function, so that's the next thing we would use. Outside of that, you would multiply by 10 and then add 40 to be the last thing. So that's going to be the first thing that you have to undo. So going up, in reverse order more so, you're going to subtract 40. You'll divide by 10 to undo multiply by 10. We'll use the inverse cosine to undo cosine. And then you'll add 2 to undo subtracting 2. So that gives us our path through this particular problem. So we'll start by subtracting 40 on both sides. If you do that, you have 5 equals 10 cosine of x minus 2. Then divide by 10 on both sides. You'll have 1/2 equals cosine of x minus 2. Now to undo cosine, you see we have to use cosine inverse. So we're going to take cosine inverse of that fraction 1/2. If you do that on the right side, that completely just leaves you with x minus 2, right? Because cosine inverse will undo the cosine. Now when you punch this into the calculator, this is the part really where the reference angle, or the principal angle, sorry, comes in. So you're just going to go over to the calculator. You're going to punch in inverse cosine of 1/2, and you're going to get this number 1.047. That's the answer we're going to go with. That's the principal value. That's the first value that the calculator kicks out. That's not the only solution in this case, but it's the only solution we're going to use. And then your last step, of course, add 2 to that. So what I'd like you to do is go ahead and hit pause at this point. I want you to try number 26 on your own. It's going to be similar to the other trig function here with cosine. Obviously, you'd use inverse sine if you need to undo sine. But give it an attempt. Hit the pause button right now. And then in a moment, I'll just write down the answer. I'm not going to go through all the work here for all of these, but I'm going to write down the answer. You can check your work. So go ahead and hit pause now. You hit pause, right? Do it. Hit pause. All right, so let's go ahead and see what the solution would look like now. Like I said, if you haven't attempted this one on your own first, do that, please. But what you should end up getting, if my answer is correct, which not always, but it should be x equals 3.142. So if you didn't get that, check the notes on Schoology, and you'll see my work that's there with the do-undo table and also with the algebraic stuff. So check that one in Schoology. All right, so let's move on to the next one. Exponents and logs. This is always kind of the one that gets students because exponents and logs don't always seem like they should go together, but they definitely are inverse functions of one another. We use logs to undo exponents, we use exponents to undo logs. So let's see what this looks like, kind of refresh your memory in terms of solving for exponentials. So we find x, we notice first of all it's in the exponent, you're going to add 1 to that x. Then it's being raised, the base is 3, is being raised to that power of x plus 1. Then I look outside of that base and power, I see I'm multiplying by 4, and then I'm adding 2 in front of that. So I need to undo all those. So I'm going to subtract 2, divide by 4. Now to undo the exponent, this is where I need the log, and that log is going to carry the same base as the exponent. So you see that's why I have a log base 3. Then I need to subtract 1, will be the very last thing that I do. So let's go ahead and get the equation rolling here with the algebraic steps. So we're going to start by subtracting 2 on both sides, then dividing by 4. So we end up with 3 to the power of x plus 1 equals 5. Now to rewrite that in log form, remember, I'm going to take log base 3 of the 5. Now if I do that on the left side, that will undo that base of 3. So notice I'm just really bringing down the x plus 1. And if I do that on the right side, I have to calculate what log base 3 of 5 is. Now some calculators, you can actually do that in the calculator, do that log base. But if you recall, most of the calculators that you're going to find here in the classroom at least, you're going to need the change of base formula. And simply by taking the log of the number divided by the log of the base. So take log of 5, divide by the log of 3, put that in your calculator. And then what we'll see is we'll get this decimal value. We'll just carry that out to 3 decimal places, so to the nearest thousandth. So we still have the x plus 1 on the left side. And then on the right side, we'll write down kind of what that decimal value is going to be. So I'm going to calculate that quick, and we end up with 1.465. And then lastly, of course, subtract 1 from that, and you get 0.465 for your answer. All right, so once again, I'm going to have you kind of hit the pause button. We're going to jump ahead a little bit, but if you notice, number 30 is another exponential equation. So this one's going to feel very similar to the one we just did on 7. So hit the pause button, attempt that one on your own, and then come back and look at the answer. And you can see the answer coming up right now, so you should end up with 13.531. So once again, if you didn't get that, check the notes on Schoology. All of my notes copied there on Schoology for you, so you can check your work. All right, next type of function, logs. Now these should be similar to the exponents, but once again, these are kind of exponents and logs. These are always the ones solving, in terms of solving, are always a little bit trickier because they don't feel like they should go together. So we're going to do in the log ones together. So if I find x, first thing I see when I'm inside that log is I'm multiplying by 5. Then I'm taking the log of that value. And outside of that, I'm multiplying by -2 out in front. And then I'm going to add 7. So when I undo all of this, we're going to subtract 7. We'll divide by -2. Now the log base there, since it's not written, is implied to be 10. So what I need to do is I need to use an exponential here, and that base is going to carry over to a base of 10. I'm putting a little blank there in the exponent because we'll see what needs to go in the exponent, but it's definitely going to need to be a base of 10 here. And then last, I'm going to divide by 5. So let's take a look at our work. Our first step, subtract 7. So we'll do that from both sides, leaving us with -2 log of 5x. And if I subtract 7, I'm going to have -158 on that right side. Second step, you see there from the undo portion, moving up that column, is I divide by -2. So I end up with log of 5x equals 79 when I divide that -158 by -2. Here's where I now need to undo the log, so I have to rewrite this as an exponential. Now if I do that, that means I'm left with what's inside the log, 5x equals 10, which was that base, to the power of what I have on that right side, 79. And then lastly, I divide by 5. Now this is a bit of a ridiculous answer because 10 to the 79th power is a very large number, and I divide that by 5, and it's still large. So I'm going to leave my answer like that. I'm not going to try and write this one out. I'm not going to worry about really simplifying that or writing a scientific notation at all. So we're just going to leave the answer like that and go for it. So 29, I want you to try that one. Notice it is a natural log. That just means your base is e. So I'm going to have you try that one, hit the pause. I'm going to go through this one, but I want you to go ahead and attempt it first. So before I get too far there, hit pause, and then you kind of watch the rest of the steps here. So if you're coming back into this, we got our do-undo table. You see on the inside of your natural log, you're going to subtract 10, then you're going to take the natural log, then you're multiplying by -1, and then you're adding 1. That's all of our order of operations. So we undo all those, subtract 1, divide by -1, use a base e because it's natural log to rewrite that and undo the natural log, and then add 10. So we carry that over to the algebraic steps. I just have to subtract 1 from both sides first. Okay, you see what you get there. Then I divide by -1. I get 301 equals natural log of x minus 10. I have to undo the natural log, so I have to use that e that's written there, that's implied to be there. So I have to raise that 301, and the base is going to be e, and the power is going to be 301. And then I'm really kind of thinking about doing that on the right side too, but I'm just going to have an x minus 10 that's left because I've undone the natural log by using the base e. And lastly, I'm going to add 10 to both sides. Once again, e to the power of 301. E is about 2.71. And so if I raise that 2.71 to the 301st power, it's going to be a really big number. So I'm not going to try and calculate that once again. Just leave it written as is. Okay. All right, our last type of one is really, to be more specific, it's a rational exponent. I see that 2/3 in the exponent. That's really the first thing that's happening to whatever x is. We're raising it to the 2/3 power. And now we're not going to change this over to a radical. We're just going to use it as a rational exponent. You see after that, you can multiply by 2, subtract 19. So when I undo all of this here, really to undo that rational exponent, I can use another rational exponent to undo that, and it's just really the reciprocal of that first one. So you see that x to the 3/2. I'm going to use that as I'm going through. So first step, add 19 to both sides. Second step, divide by 2. Now, when I raise both sides to the 3/2 power, that will undo the 2/3 power, and I have to raise the 30 to the 3/2 power. And you can calculate that in your calculator. Punch it in, do 30 to the power of. You may have to put parentheses around the 3/2, but it'll be the power of, or exponent, 3 divided by 2, and then you can see your answer there at 164.317. Okay. Lastly, and notice I'm writing the answer up there, but go ahead and attempt that last one on 32. Should be similar to 31, that rational exponent that's in there. Go through, try that one, attempt it. Once again, any of these are posted to Schoology. You can, of course, go back. We've gone through a majority of those problems that are on there for the last 2 days in your notes while I'm gone. And so you've got a lot of examples to look through. You can look through the videos once again. But you'll notice the next kind of step here is if you kind of start to feel a little bit comfortable with a lot of this process, next step is the practice. So you should be getting a practice worksheet where there's another set of these. I think there's 15 more of those where you're going through and just thinking that do-undo process that's there. And if you're feeling confident here and you're not needing to actually show that table, you don't have to show that table at this point. You can start dropping the table, but it's still a thought process that you're going through to figure out how to get that equation started. What's your first step to solve? Oftentimes, you need to think through the order of operations and figure out what's the last thing that's done in the order of operations, because that's the first thing you have to undo, and then you can work your way backwards from there. So hopefully the do-undo table makes sense to you to be able to have it be something you can start working on mentally to have a solution or to find a solution for these types of equations. So that's it. If we have any questions, once again, check Schoology, watch the videos, and then go through and check the notes. And I'll be back next week.